Hello and welcome to the absolute best thing on the entire internet. Here is the priceless URL and there should be a link on your Blackboard site. So the aim here is to demonstrate what happens when we sample and why it is we take a sample of more than one individual and why a bigger sample is usually preferable. So the setup is that in the top diagram here we are shown the distribution of the individuals that we're interested in. So this could be the income of all individuals in a particular area, or the yield of crops in terms of kilograms per hectare in all the fields in a particular area, or the weight of all fish in a particular lake, or the size of all trees in a forest. So these are the individuals here. So if we went there, let's say to a rural area, and we selected one particular household, so that's your one individual, it's one household, and said, okay, what's your mean income in this household per person? Well, what we're trying to work out probably is whereabouts is the mean here. But we can't see any of this, so we select an individual at random and look at the shape of this. We'll probably get one around here. That's what this shape is showing us, that most of the time we are going to get something that's roughly around the mean. But we could pick someone here, and it's a bit of an overestimate, or here, that's an underestimate. We could even pick someone up here, and that's the only value you have to go on. You think, oh look, the mean is this, but it would be a big overestimate. Or we could pick something down here. That could happen. It's maybe not that tiny a probability. You could pick someone down here and then you would tremendously underestimate the income in that area if you only have one to go on. That's why we don't take just one. Let's just see how taking a sample improves this. And what happens is you press animated and it takes a sample of 5 and puts it here and shows the mean of the sample. At the same time, we're going to, the bottom one down here, if you're following this, make sure you change this on your version. We'll go for the biggest possible sample, which is 25 here. So it's going to take an animated sample of 5 from the top. Here we go, 2, 3, 4, 5. And there's the mean. Now it's taking 25 for the bottom one. That's 25 individuals, and the mean of those individuals should be there. Okay. So we can say in both cases it's been a slight underestimate. Now what we're doing here is, remember this figure is no longer one of the original figures. This isn't one of the original ones we drew. This is the mean of 5 and this is the mean of these 25 here. Yeah. So what you do when you do a survey is you do this. You take one particular batch of say 25 and you get one particular mean. Now the point I'm trying to make in this video is that this is all you can see. You can't see any of this stuff up here. You just see that and you want to know where is the mean of the population. We know it's here, but when you're just looking at this, you don't know. So what you want to know is how near is this likely to be? Or how far is it likely to be from here to the true population mean? And in order to understand that, you need to know something about all the possible samples that you could have picked. Maybe you could have picked a sample and got the mean up here. Or you could have picked a sample and got the mean down here. You need to know how these possible sample means are spread, because you're basically picking one possible sample from all the possible samples that you could theoretically ever pick. So that's what we get now. We need to draw a picture of a few more samples. So that, if I do press 5 here, here is the mean of the 5, or it's 6 now, because we picked 6 samples of size 5 and here are the means. And we picked 6 samples of size 25 and here are the means. Still can't really get much of a picture of what's happening, so let's up the scales a bit and take 10,000 samples and maybe 100,000 samples, or another 10 and then 100,000. Okay. So now we've taken quite a lot of samples. You can see we've taken about 120,000 samples here, 120,006, and now you can see a bit of a pattern starting to emerge. For the samples of size 5, these are the possible means in here, and for the samples of size 25, the possible means are in this range here. Now this is really revolutionary, because it means that when you take, if you look back and see what happens when you're taking a single individual, you're picking a single individual. It's quite likely to be around here, but you could quite easily get one up here or down here, and then that individual would totally mislead you about where the true population mean is. But if you just take a sample of 5, you're going to get one around here somewhere. There's just no, it could theoretically happen, but it's incredibly unlikely you'll get a sample of 5 and get the mean down here. Where it's fairly likely you could get it with an individual. sample of 25, it's incredibly unlikely you'll even get the mean as far down as here or as high up as here. So you're almost certain, in probability terms, with a sample of 25, you're almost certain to get the mean in this area, which means your estimate of the underlying population mean is going to be somewhere around here. So it's going to be very, very accurate. So that's one of the reasons we like to take a sample and as big as possible, because that range of possible sample means that you're picking one sample out of becomes much more tightly concentrated around the true population mean.